Hello, this is Ms. DB. In this video, we are going to go over some of the problems from the graphs of linear equations. So this is an important assignment about how to graph lines and how to graph vertical and horizontal lines as well. There is a matching section of your book that would help a lot for this assignment, but we'll go over some of the questions as well. So first off, we have what are the solutions to an equation in two variables? This is from the reading in your book, but the answer to it is if you have an equation in two variables, like y equals 3x, the solutions are all the points that are on this line. So the solutions are coordinate points, and they'll have an x value and a y value. For example, let's look at this point right here. This is the point 412. The point 412, it would be a solution to that equation. And this is different from an equation in one variable, because if you just had one variable, like y equals 4, the solution is just that point. So it's like if you had, I'm going to write it over here. If you had 2x equals 10 and you solved this, you would get it, you divide both sides by 2, and you'd get one answer, x equals 5. So that's just a number that's the answer, and the solutions to an equation in two variables is all the points that are on that line. The equation for the x-axis, here's the x-axis down here. It's the horizontal one, and the equation for that is going to be y equals 0. See how the green line graphed right on top of the x-axis? So the equation for the x-axis is y equals 0. The equation for the y-axis is x equals 0. See that purple line that graphed right on top of the y-axis? So yeah, it's x equals 0. And in fact, all horizontal lines will be y equals some number. All vertical lines will be x equals some number. Then we have a couple problems. We're just going to be using a graph that has a line graphed on it. And this says this is from the book. It was a different problem from the book, but we're going to use the same graph. And it says determine the net cost of an item costing $8. So the price including tax is here. They want you to look for that price. And this is the price before tax. They want us to say what is the net cost of an item costing $8 including tax. So the price before tax will be 8, and they want to know what will it be after tax. So we would go up here until we hit this line, and it looks like the price after tax would be $9. The answer for that one. And then on this one, it says using the temperature graph from the lesson. So again, this is a graph from the lesson that had some previous problems already used on it. That's what the red lines are for. Determine the following. The Fahrenheit temperature of 0 degrees Celsius. So Celsius is along the y-axis, so we would find 0, and we would trace that until we get to the line, and it's right a little bit more than 30. And you might know that that would actually be 32 degrees because that's the freezing temperature of water, and it's 0 in Celsius and 32 in Fahrenheit. So the next one says what's the Fahrenheit temperature of 30 degrees Celsius, so then you'd go up to 30, that one has a line there, and you'd go over and see where it hits the Fahrenheit temperature, and it looks like it's about 85. And then the Celsius temperature of 0, that means you find 0 on the Fahrenheit scale, which is, well, 0's right here, and the Celsius temp, you'd have to go drop down until you get to that line, and it's like negative, 17 or so? And then the Celsius temperature equivalent to water boiling, you might have to look that up, but it's 214, and that's not on here. So that might be one you'll have to Google and find what is the Celsius temperature at when water boils. All right, then it says to graph the following equations on the Cartesian planes. You can graph 2 on each graph. So I had said earlier that every horizontal equation will be y equals some number. So I know that it's going to be a horizontal line. Let's graph it on here to see what it looks like. Y equals -2. It's a horizontal line. Here, let me hide these two. That's going through at -2 on the y-axis. So we can graph it on Desmos if you want, or you can go to Insert. Let me move this down so you can see what I'm doing. in Word, you can go to Insert, and then you can go to Shapes, and then find a line. I'll use this line. And I want to draw a horizontal line through y equals -2. I'm going to just make this a little bit thicker so you can see it. So there's my line that goes through y equals -2. To graph x equals -4, that's going to be a vertical line. Let me look and see what it looks like on Desmos. X equals -4 is a vertical line going up and down through -4 on the x-axis. So I'm going to insert another line. Once you insert one line, it'll come up on your recently used shapes, and I need to make a horizontal or a vertical line through there. And again, I'm going to make it a little heavier. Maybe I'll change the color too and fatten it up a bit so I can see it. And then you would do the same thing. Use this one maybe. Y equals 4.5 will be, right in between 4 and 5, a horizontal line. X equals 3 will be a vertical up and down line. And you can also graph them in Desmos and then attach a screenshot of this. All right, let's keep moving on. Number 7 is very much like number 4, 5. We're looking at a line that's already graphed, and we can see kilograms are on the bottom and pounds are along the vertical. So to change 4 kilograms into weight in pounds, you would find 4 along the bottom, and you would go up to the line, and then you'd go over to see what that would be in pounds. That looks like about 9 pounds. And you keep going like that. Okay, number 8 is very important. Number 8 is what are the equations of some horizontal and vertical lines that are already graphed. So line A is right here. That's a horizontal line. Remember that horizontal lines are always going to be y equals some number. So, and it's going through at 5. So 8a would be y equals 5. And B is also a horizontal line, so it'll be y equals some number, and so is C. Let's do D. D is a vertical line, and it's going through, look at, we did this one already. D is this one right here. It's x equals, because it's vertical, and then it's going through at -4. So x equals -4 is the equation. If you don't have the y equals or the x equals, it's wrong. That would just be a number. Okay, and then number 9 says at the airport you can change your money from dollars into euros, money used over in Europe. The service costs $5, and for every additional dollar you get 0.7 euros. So if we let x equal our dollars and y equal the euros that you will end up with, then we could say that our euros is going to equal $5 flat fee, have to pay it no matter what, plus, let's see, for each additional dollar you get 0.7 euros, so that would be times x because that's what your euros are. Or you could write this as 0.7x plus 5, either one of those is correct. So then for the table, let's say if we, zero is kind of an easy one, if we were silly enough to do this for $0, we would have to still spend $5 because 0.7 times 0 is 0 plus 5 is 5. If we did it for, like, say, $10, then we would have 0.7 times 10 is 7, plus we had to pay $5 just for doing this, so we would get $12. And then maybe we would do this at $20. Let's see what we would pay at $20. That would be 0.7 times 20, and then I'll add 5 to that. That's 19. Anyway, you would do a few more of those, and then you can plot those points on the graph. So on the graph over here, I'll use, each space will be 10. So I'm going to, I'm just going to draw. I'm going to put a point at 0, 5, so I guess that's like part way. There's one point, it's kind of small. And then at 10, I'm going to go up to 12. And then at 20, I'm going to go to 19, so that's almost at 2020. And then I would keep going, and they should all be in a line if I've done the right steps here. And then I'm going to draw a line through my points, insert shape, and I'm going to make my line go through. That is not what I wanted it to do. I kind of did it on its own. Insert shape, line. I want my line to start just about at 5 and then go up through those points. And I don't need to do the negative part because it doesn't make sense that I would go there with 0 or less dollars. So it looked like that. You can also graph this in Desmos. Let me show you how. So I could write my equation. I would have to figure that out first. 5 plus 0.7x, or 0.7x plus 5. And the line graphs for me automatically. If I wanted to get a table of values, click on the edit list, and I'm going to change this to a table. And then I can change these values to what I wanted them to be. I wanted them to be 0, 10, 20, maybe 30 and 40. And then your table of values is also found for you, and you can fill those in over here. And then again, you can take a screenshot of this. Or in Desmos, they have this share button right here. I could get a link to this graph, and then I could paste this into my assignment, and then that link lets me check your work. So if you want to do it in Desmos, that would be cool. Okay, then there's some problems where you are going to have an equation and you're going to graph the lines and make tables. Again, you can use Desmos to help you check these, but you should try them on your own. So number 10 says, think of a number, triple it, and then subtract 7 from your answer. So this one doesn't have an equation yet, so we need to figure out what we're doing. So my number is going to be x, my answer will be y. So I'm going to take x and I'm going to triple it. That means I'm going to multiply it by 3. And then I have to subtract 7. So I just write minus 7. That's my equation. Now I'm going to pick some values for x. Maybe I want to pick 0, 1, 2, and 3. So to figure out at 0, I would go y equals 3 times 0 minus 7. And 3 times 0 is 0 minus 7. So at 0, I would get y equals negative 7. So I put that into my table, and then I can do another one. And when x equals 1, I would have y equals 3 times 1 minus 7. So then I would have y equals 3 minus 7, because 3 times 1 is 3. And then that equals y, 3 minus 7 is negative 4. So that one would be negative 4. And these should, when we graph them, they should be on a line. So the next one would be y equals 3 times 2 minus 7. So that would be 3 times 2 is 6 minus 7. And that equals negative 1. 6 minus 7 is negative 1. So that would be my next value. Let's graph these. You can do one more, but let's graph these on this table. So I have 0. At 0, it's at negative 7. So 1, 2, 3, 4, 5, 6, 7. Make this a little bigger for my own sake. And my pencil tool didn't stick. 1, 2, 3, 4, 5, 6, 7. Right there. And then at 1, it's at negative 4. So 1, 2, 3, 4. Oh, I have to do it again. 2, 3, 4. Draw. Frozen or something.